All right. We are in the last two videos of our videos this evening. I tried to make them a little bit shorter and then give you some independent reading time. And again, remember, it doesn't all have to happen on the night of, but you definitely want to finish it before the week we meet next. So if we think about our CGI principled ideas, the details of student thinking support instructional decision making. So the more we understand how student thinking lies in the standards of math practice, in the content standards of the grade level, the better we're able to make some decisions about what should come next, what types of questions we should ask, and what we should be concerned about or celebrate. So we're going to now look at the mathematical frameworks. And as I mentioned, we are in a situation where we're in a state of flux because we have the mathematical frameworks that were published in 2014. And now we are having a new round of frameworks being published in November of this year. Those frameworks are still under review. The mathematical frameworks from 2014 are still excellent resource documents for you. So we are going to take a moment to look at them because I think they will remain effective documents in the coming years, even if we have new frameworks. So when we think about learning progressions, how students move from one strategy to the next and understand new concepts, the standards of math practice explain the practices or habits of mind students should develop. The content standards tell us what students need to know. And the frameworks help teachers have clarity about research-based learning progressions and common misconceptions. They are excellent documents that you should have and understand where they are and read them, especially before you start working with a particular grade level. So with respect to the learning progressions, understanding the way students learn is key to facilitating their growth as mathematicians. And as I mentioned earlier, there is a lot of research, especially now, about how kids learn and what are the best practices to help create learning opportunities for that. So as educators, we want to know those milestones and common misconceptions that help teachers elicit and respond and help move kids along to more sophisticated strategies as long as they have conceptual understanding, right? So it's not procedurally fluent if they don't understand why it works, right? So we want to employ mathematical reasoning and make sure that students have conceptual understanding as long as it makes sense to them, and then they can use procedures that also make sense to them in the context of the problem. So, understanding the developmental progression of how kids learn impacts our teaching, as this helps us determine which tasks to select, what questions to ask, and which strategies to share, and in which order and why. And so, we are going to be looking at this in the coming weeks. We're going to be looking specifically at different types of questions. We're going to be looking at different types of tasks and different types of strategies. So, here are the frameworks from 2014. And I also will give you a link to the 2021 revisions. It's actually you can find it on the same page. So we'll just take a look at that right now real quick. So if you go to the mathematics frameworks page, which the link is on your Word document, you see here that they have the 2022 revision kind of front and center. And then you can read all of these chapters. It's a lot of reading, and we're not going to do that right now. What I want you to do is go to the 2013 mathematical framework chapters. So you'll go here, and then you're going to pick whatever content area you just read. Let's say you read grade 5 or grade 8 or algebra 1, statistics, whatever it was that you read, you're going to go to the framework for that content area. So if you read grade 2, you're going to go to the mathematical framework for grade 2. Okay. And you'll see that there are all these fabulous things in here. So let's just take a quick tour of what kinds of things the frameworks offer us as educators. So they offer examples, grade level examples of the standards of mathematical practice. So what do the mathematical practice standards look like in grade 2? What do they look like in grade 6? What do they look like in grade 9? So this is a wonderful touch point for us as educators to see how these standards are manifested in the context of the classroom in the grade levels that we teach. The mathematical frameworks are resources to help you know how kids progress from one strategy to the next. They offer methods of solving, and they give you different levels of strategies, which are very similar to the research done by the CGI group coming out of the University of Madison, Wisconsin. So they talk about level 1 strategies as direct modeling strategies. They talk about level 2 as counting strategies. And then level 3 is converting to an easier problem or doing invented algorithms. So this helps us as teachers figure out what we're going to select first, next, and last, sort of like I did with the Acrobat problem. And also it helps us to figure out when we ask those questions, where are we trying to nudge those kids along in their thinking? So this is a really great document, and you can have it at your side as you're planning your lessons. Another wonderful thing that the frameworks offer is descriptions of common misconceptions about important concepts at your grade level. They also define rigor, focus, and coherence. That how do we want to have this included in our mathematics programs? They discuss key ideas such as fluency and how fluency does not mean speed, but it means it's more of a relational understanding, and students are actually given time to think relationally and still be considered fluent. So, what are the implications for teaching for us when we look at these mathematical frameworks? Well, this is how we figure out what the art of teaching is. We build new knowledge from prior knowledge, both as teachers, just like we want to ask our students to do. We provide opportunities to share and communicate about mathematics and create opportunities for reflective thought. So these frameworks also encourage multiple approaches and time to make connections for young people. They engage students in productive struggle, which is very important. And that space is something that we have to become comfortable with as educators, that there is this space where students are thinking about using what they know to figure out what they don't, but it's not immediately apparent. And if we jump in, we arrest that thinking process. So we need to give kids time to engage in that productive struggle. We want to treat errors as opportunities for learning and create a classroom environment where students listen to each other. Remember the norms that we talk about each week. So what you're going to do now is you're going to read the frameworks for your grade level. I realize that they are quite lengthy, so if you cannot finish them tonight, please go ahead and finish them before we meet next class. And then what I'm going to ask you to do is visit the Jamboard for the very last time, and you're going to respond here. What did you notice or what resonated with you in the framework? So this is your final Jamboard entry. And then we are going to have our closing slides and just sort of talk about a little bit of a preview of what's coming down the pipe. And then I will see you next week. Have fun.